Our aim for today is that we are going to be graphing linear equations in slope-intercept form using plug and chug. So, following up on our video notes. Oop, get a little excited there. In this video, it says that equations are typically solved for y. Okay, we call that slope-intercept form. We are going to run into equations that are not in slope-intercept form, so we're either going to have to use different methods to graph, or we're going to have to put them in slope-intercept form. So we're going to learn about that later on in this unit. According to the video, what are the 5 steps in order to solve an equation, graph a linear equation? What are the 5 steps? Step number 1, somebody with a raised hand. Katie. Construct a table. Yeah, I know. I'm over it. You guys know what that one says. You guys got that one all down. Step number 2. Rebecca. Choose x values. How many of them?
Several. 3.
So it said several in the video. Specifically, I said how many? 3. Step 3. Surely somebody else got this down there whose name is not Javier or Rebecca or Katie, because they've answered all the questions so far. Graciela. Substitute each x value into the equation. What's another way that I said that we could describe this particular step? What word did I use to describe this particular step, Manuel? This is the plug portion of the plug and chug. Step 4. Michael. Find the corresponding y values. And in terms of a one-word response to what this part is, what is one word I can use to describe this? Chug. So that's the chug portion of plug and chug, or as my professor would say, he would call this cranking it out. All right, last and final step. Katie? Graph the x, y pairs. Oh, that's all over in the wrong place. There we go. That's much better. All right. That's a win. I feel like that's a tool that I don't normally get right. All right. Technically, how many coordinate pairs does it take to graph a line? Show me the fingers. Technically, how many does it take to graph a line? Those of you who are showing me 2 are correct. So technically, to graph a line, I just need 1 point and 2 points, and sure enough, I can get a line through them. Now, how many did I say we were going to use? The video said 5. I said 3. The reason why we're going to use 3 is because we're going to take those 2 points that we used to graph the line, and the third point's going to check. If the third point is like right there on the line, that means everything's all good. If that third point is way off over here, that means something's wrong. Okay, one of our 2 points, or maybe even our checkpoint, is wrong. Okay, that's why we're going to use 3 points. The solution to a linear equation is a. Somebody fill in this blank for me. Solution to a linear equation is a what, Raisa? What does it graph like? Malcolm, help her out. That is one solution, but I'm talking about the global solution. It's not just a coordinate pair, it's a line. That's a very important distinction. Sorry, that's line. I'm going to try that again. Solution to a linear equation is a line. Now, how do we know an equation is a linear equation? There's two correct answers here. One that I haven't told you yet, and one that was given in the video. What's the one given in the video, Katie? Yeah, when it graphs a line. Now, the second thing I'm about to tell you is something that you've got to keep in mind, and it's how we're going to recognize linear equations this year. It is not a perfect definition for a linear equation or how we recognize a linear equation when we look at the equation. Okay? What I'm about to tell you will not work when you get to Algebra 2, probably, because there are going to be other things that will fit this description that will not graph lines. But for what we need to know this year, I'm going to tell you that a linear equation, when we see it, is going to have two variables. And no exponents. Okay, that is not a perfect definition. Okay, like I said, you will run into equations in your lifetime that will fit this description that will not be linear equations. But this is a good enough working definition for us to use this year. Okay. All right, looking over here at our example. This is actually the exact example from the video. And I have chosen the three x values that I think are the most important. One of the most important things about solving these equations and being able to graph them is choosing appropriate and easy x values. The easiest x value to use at all times, without exception, is
1.
Incorrect. 0. The reason why 0 is so great is because we know anything times 0 is 0. Anything plus 0 is
The same.
itself, the same, whatever we want. So when we plug in 0 into the inequality, or the equation, notice I've rewritten the equation. This time I'm just rewriting it and I'm substituting in 0 instead of x up here. That's all I've done here. 2 times 0 is 0 plus 3. And 0 plus 3, 3. That makes it really easy. 0 is always an excellent choice. Always. The other one you suggested was 1. 1 is definitely a good choice. Most of the time. We're going to actually see a couple problems today where 1 is not going to be so good of a choice. I'm going to plug in 1 down here. 2 times 1 is 2 plus the 3. And 2 plus the 3 gives me 5. So that's going to be our second coordinate pair. Now, the third one is always up to you. I always like to choose coordinate pairs. And I like to have one on each side of the y-axis. So I usually choose the negative of whatever positive value I chose. So I had 1 over here. So usually my other value I'm going to choose is negative 1. 2 times negative 1 for me. Check that out. That's a bad date, so that's negative 2. Good dates and bad dates, like signs add, opposite signs subtract. Super important in this unit. If If you don't pay attention to those things, you're going to get 2 points that look really, really great, and then a third point that you're going to be like, oh, what happened? All right, -2 plus 3, that's opposite sign subtract. Take the sign a larger number, +1. So we need to come through and fill out our table. I chose -1, 0, and 1. Those were my x values. When I plugged in -1, what did I get for my y value? Gene, when I plugged in -1, what did I get for my y value? Hopefully it's on your paper because it's not on mine right now. 1. When I plugged in 0, what did I get, Janelli? 3 was my y value. And when I plugged in 1 for x, what was my y value, Christopher? This one's actually staring you right in the face. When I plugged in 1, I got 5, right. So when I plugged in the 1, I got the 5. All right, so now all we got to do is we got to graph these points. So I'm going to zoom in over here to our graph. -1, 1. This is something that you all showed me you are quite proficient with. 0, 3, so that's over 0 and up 1, 2, 3. And over 1 and up 5. 1, 2, 3, 4, 5. Now, this next part is super, super important for me. Because engineers, scientists, mathematicians use graphing of lines as a tool, it's super important that your line be as accurate as possible. You can't draw an accurate line without a straight edge. So I will not accept work that is not drawn with a straight edge. And then a bunch of you are about to say, well, Mr. Boots, I don't have a ruler. All of you should have what's usually a pretty excellent straight edge, which is your independent reading book. For me, I usually take a piece of paper, because I don't always have an independent reading book on hand. I fold it into 4. That usually gives me a nice straight edge, and it's usually thick enough for me to be able to run my pencil across. Okay, super important that you draw a straight line, because that line is going to be used, not necessarily today, but in future units, to make sure that we have to find some other solutions. So I'm going to draw my line. Oh, need pencil mode. Pencil mode. Straight through all those points. I do my best. Hater. Okay. So, I will not accept work without straight edge lines. I will just mark it wrong. I won't even look at the rest of it. Okay, I want us to flip over to our... And I want to discuss these 2 problems. What I want to discuss about these problems is simply choosing appropriate x values for these problems. So, this first one, by the way, I have mistyped the equation. Yep, I want y equals 5x minus 5. Now, one thing actually about this equation before we even get started on it, you're going to see that this equation has subtraction in that. How do you think I'm going to feel about that subtraction? Yeah, leave, change, switch it right early. I hate subtraction. Do it right away. That way you don't have to do it every time you start plugging and chugging. Thinking about appropriate x values. What's the first x value that you think you want to choose here, Jose? One would not be my first choice, although 1 is a good choice. Yeah, 0 is always my first choice. 1 here's a good choice, pretty solid, and third x value. You're saying 2, I'm going to go ahead and say -1. 2 is not a bad choice here. One thing that you have to be careful of is sometimes if you pick certain x values, they're going to give you y values that are off the chart. That's not going to happen here with 2. I always use 2 different things on opposite sides of the axes. So I usually use one negative number and one positive number. Now, this next one is the super important one and the one that you have to be crazy careful about here when you're choosing your x values. The first x value that you probably want to choose is what?
5.
First x value you want to choose is 0. Now the next one, I want you to be really, really careful about it. Looking at the equation and the multiplications and subtractions that you're going to have to do. What do you think would be the next x value you would want to choose? Rebecca. Rebecca says 2. She has skipped right past 1 and gone on to 2. Can somebody explain to me why she might have done that? Kenneth.
Because 1 times a half of the half minus 3 is the
You can stop right there, Kenneth. So what Kenneth is saying is if we choose 1, we end up getting this multiplication to be negative 1/2. Now we're suddenly dealing in fractions. Fractions are a lot more difficult to deal with than whole numbers. They're harder to graph, they're harder to do the addition and subtraction. So what Rebecca has suggested is that we use 2, because when that multiplies together, that's going to give me negative 1/1, which is just negative 1. That's going to be a lot easier to add to. It's going to be a lot easier to graph. Fernando. So when we're dealing with these particular problems that have fractions that we need to multiply by, choosing the denominator is always a best second choice. Then I usually choose the opposite of the denominator. Instead of 2, I'm going to choose negative 2. What other values do you think would still be good, though? Marlon. Any even number, any multiple of 2, so 4, 6. All of these things are going to give us whole numbers when we multiply by 1/2. Let's do one more quick question. If I had given you the equation y equals negative 2/3 x plus 5, what would be good x values for this? Manuel. 3 would definitely be very good because that's choosing the denominator. That's excellent. What else? Janelli. 1 more time. 6. That's a multiple of 3. That's an excellent choice. What else? Fernando. Negative 3. The opposite of the denominator. Excellent choice. And the one that we're all missing here, because it's the obvious, is 0. So all of these are good. You can go with negative 6, negative 9, 9. Any of these multiples of 3 are totally excellent responses, okay? So when you have that fraction that you're multiplying by, you're always going to want to choose an x value that is a multiple of the denominator. Just makes it easier to work with. Are any questions before we move forward with the rest of our Together Time work?